Good morning, everyone, and very happy Dashera to everyone. And let's try to kill the evil within and make this yoga a better place to live. Right. With that, let's start this demo session. And this demo session is on computer networks, basic to advanced. Right. And in this course, and as we will discuss in this demo session later as well, we will be going through what is computer networks, why was it created, and how does basically computers on different networks or through the internet they communicate with each other. This is what we will be going through in this whole course. And in this demo session, I will be just giving you a glimpse of what we will be learning and how we will be learning, the time, the duration, the course length, etc. Right. So let me introduce myself first. I am Laksh, and I am currently working with Cisco, and I have 10 years of experience. And uh, most of you would have either seen my email if you're working on in Cisco, or if you are not from Cisco, you would have seen my posts on LinkedIn as well. So to contact me on LinkedIn, you can search my name, my full name, which is Lakshmikant PS. You can search me over there, and we can connect on LinkedIn as well. And this course is open. I mean, it's open for everyone. There is no prerequisite for this particular course. You can be from any background. You can be from a non-technical background as well. It's open for all. And also it is free, right? This is not a paid course, right? You can, anyone can join and from any background, and there is no cost involved. So yeah, so this is an open and free course that I'm going to deliver. So getting started with that, let's try to understand the world of internet that we are surrounded with. Okay, so we are, even now, like when I am giving this demo session, we are connected through the internet. And in most of our sessions, I will be giving real time examples. Okay, so let us use one of those real time examples, like when we use internet. So we use internet for a lot of things. We use internet for mostly to surf the net, to scroll over the websites like Facebook, Instagram, etc. Right. And we use internet to Google something, okay, to learn new things, to research on something, to find some answers that we are not aware of, etc. We use it for banking transactions, etc. So we use internet for a lot of things, right? And like in front of you on your screen, the picture you see here is a very simplistic picture, right? So you can consider yourself as this person on the left. This is you, and this is one of your friends, right? So you both are talking to each other over Facebook, for example, right? So the only thing that you basically see physically is your mobile phone, right? Is This is what you see is your mobile phone, and your mobile phone connected to your Wi-Fi router or Wi-Fi modem, right? That's all you see, right? Similarly, your friend who is on the other side of the internet, right? He will also be using a device, probably a laptop or a phone or his iPad or whatever, right? And he or she will also be connected to his or her internet modem. So this is the only physical visibility that we have, and we assume that we are connected to the internet, right? Yes, that's partially right. We are connected to the internet only through what we see. However, right, the internet is beyond, again, it's beyond our imagination, right? So the internet is between your Wi-Fi router and your friend's Wi-Fi router, right? And that world of internet is huge, and it is beyond human comprehension. Okay, the amount of data, the kind of protocols, the kind of technologies involved inside internet is huge and is beyond our comprehension. And in this course, what we are going to look at is how to simplify this comprehension. You know? So just like how Lord Krishna like simplified the whole comprehension of universe and how things happen around, like to Arjuna, same way we will try to bring down, or we will try to like the comprehension of internet, like the imagination of internet, the or the entirety of internet into a very very simplistic and basic thing. And this is what is this course about, trying to understand how things work in the internet in the very basic form. All right, now before we jump into that discussion of internet, I would like to understand from each of you, whoever is present on this call, what is your understanding of internet? What whenever you hear the word internet, or whenever you talk about internet, or you think about internet, or whenever you are on the internet on your phone or on your TV or on your laptop, what is going on? What do you understand by the word internet? Can someone tell me? There's no right answer, there's no wrong answer. It's internet, to be very frank, is a very subjective answer. Okay, so it everyone can have a different way of looking at internet. So I want to know from everyone on this call, what is your understanding of internet? Can someone tell me?
Just actually like a connection of different nodes placed in different geographical locations from which we can have sharing of digital data.
Okay,
So that's the
connection
basic
of nodes,
nodes in a
sharing
different
of data.
different geographical location with sharing
Okay,
of data, digital
all
data.
right,
That is not
all right, fine. Anyone else? Anyone else would like to share their understanding of what is internet? Okay. So as someone said that it's a connection of nodes, it's a connection of nodes on in different geographical locations to share digital data, right? Yes, which is, as I said, it's a subjective answer, so it's right as well, right? It's one of the definitions of the internet. But let's just try to understand the word internet itself, right? So the internet is, people think internet is a word. No, it's basically a short form, and internet is a short form of interconnection of networks. That's what you call it as internet, right? So inter Okay, someone has messaged on chat saying network of networks of smart devices. Yes, that is also one way of looking at internet. So as I was saying that interconnection of networks is what you call as internet, right? Now, what is network? As I mentioned, interconnection of network. What is network? Okay, so let's go back to our same example. Okay, this is your mobile phone. Okay, and you are connected to your Wi-Fi modem. Okay, you are connected to your Wi-Fi modem, and it's not just your mobile device. Obviously, in nowadays in a family of four mobile devices are there, right? So four into different mobile devices connected to one single Wi-Fi router, and not just mobile phone. Your laptop is also connected to the same Wi-Fi modem. Your smart TV, okay, your smart TV is also connected. Nowadays, there are smart fridges as well. Smart fridges are also connected to a Wi-Fi modem, etc. So what is happening? So these mobile devices, or these devices which are connected to your Wi-Fi router, are themselves forming a small connection or small network. What is a network? In simple words, it's basically a group of people, group of devices, or group of some objects which have similar interest. Okay. group of objects which have similar interest is basically forming a network. So here, mobile devices, smart TVs, laptops are forming a small network for themselves, right? Similarly, as I said, your friend is also your friend is also living with his family, right? So he will also have formed a small network for his home, right? So his phone would also be connected to a Wi-Fi router, right? A mobile phone, and not just mobile phone, every other mobile devices, smart TV, laptops, etc., are connected to the Wi-Fi router. So it has formed a network. Now, this is just one small example of network. Again, there are big networks as well, which does not involve just these mobile devices. There are networks which involve computers, which involves servers, which involves supercomputers. So you can see here in the diagram, right? So this, let me change the color. This is a network of CPU or servers, right? This is a network of a corporate company. This is a network of different PCs, right? And this you can see is a network of supercomputers. So if you can see all of them, okay, we are not just able to communicate with our family, we are also able to communicate with your friend's family as well, basically some other network as well. So it's internet is basically an interconnection of these networks. That's what we call it as internet, interconnection of networks. Many people think Google is internet. Google is internet or Facebook is internet. Many people think Netflix is internet. Many people think they're a bank a bank website is internet. No, that's not an internet. Google is a network. Google has its own network. Facebook has its own network. Netflix has its own network. Bank website has its own network. All of them, all these things are connected together. And that's what you call it as interconnection of networks. And as I said, in this course, we are going to learn how are these different networks connected together. Because of their connection, we are able to talk to these different networks. And that is what the study of computer networks is all about. Okay. Any question or anything you want to add or you want to correct uh, uh, before I move on? Anyone? All right. Now, as I said, we will be learning about the computer networks with all the real world examples. Okay. As I was giving you the example of your friend and ourselves talking to each other over internet. Similar small real time examples I will be using so that it's easier to relate and it's easier to visualize computer networks. And because until unless there is a visualization, right, it's not fun to understand just the theory part. That's why I'll use all the real time with pictures, etc., in order to make things easier. But before we jump into okay, but before we jump into further discussions, I'll I'll give a brief about something, okay, and therein we'll move forward. And do not worry if you do not understand whatever I'm trying to take in this demonstration or whatever you see in the picture. If you do not understand, do not worry about it because, as I said, as we move further in the whole course, we will go through each and every of these diagrams that you see in front on the screen. one by one, step by step, slowly and steadily. Okay. Now, anything, okay, anything in the world to run, it needs kind of a rule and a regulation. Okay. Even in your home, your parents or us, if we are a parent, we keep some rules and regulation how to move around in the house. We can't keep things anywhere, right? We like to keep things clean, neat, tidy, right? When a few of our friends or relatives are coming, this is how we are supposed to behave. This is how we are supposed to talk, right? And even when we go out, we are supposed to drive. We are supposed to follow the traffic rules in order to keep things or vehicles move smoothly. A lot of things. Even when we go to the office, there are some rules and regulations, etc. Right? So in this world, everything is based on some rules and regulation. And if there are no rules and regulations, the world is going into a chaos. Right? Similarly, in the world of internet, there are some rules and regulations. Okay. And in the world of internet, those rules and regulations are created based on something of a model. And that model is called as an OSI model or a TCP IP model. Okay. The full form of OSI is Open Standard Interconnect, and TCP is Transport Control Protocol or Internet Protocol model. Okay. So these are the models or the kind of departments, I would say, which basically set the rules and regulation of how your internet should work, or how the data that is or how the data that is following, okay, how the data that is flowing in the internet should flow or should follow the rules in order for no congestion to happen in the. And yes, just like we have traffic congestion in our roads, we also have traffic congestion in the world of internet as well. Okay. So if the rules are not followed, you will have traffic congestion on the internet. And we usually see traffic congestion on the internet as slowness of internet. Sometimes we are surfing on the internet, we are watching some movie or we are watching some video on YouTube. Suddenly the video gets stuck, or suddenly the quality of the video drops down, right? That is because of congestion in the network. We'll talk about that probably later, but let's try to understand how and why these congestion, or sorry, why these rules matter. Okay. So in the world of internet, okay, there are 7 layers. Okay, you can see these 7 layers over here. Okay, we'll go one by one in through these different layers, and we'll talk about what and where do we see these layers in the internet. Okay, so these 7 layers, as you can see, is not in the internet. They are present in every networking device. Every networking device. When I say networking device, I mean that any device that can be connected to the internet. Any device that can connect to internet, in my understanding, is a networking device. And every networking device, please, I'm emphasizing on this particular statement, every networking device has these 7 layers. Okay. And based on the usefulness or based on its feature, the device will run on few of these layers only. It's not that every networking device will use all these layers. These layers are inside, as I said, are inside the device. Okay. How are they integrated? They are integrated on your chip, the motherboard chip. You will see capacitors, diodes, etc. And you see you have microprocessors, etc. These layers are embedded inside those things, and these layers come into play based on the features that we are going to use on that device. Okay. Though what are those devices, how they are used, we will talk about those devices in some time in this session. Okay, and we'll go in depth in further sessions.
Yeah, Laksh,
Okay.
can you take one example of one device and show how all
Yeah, yeah,
the layers are there? Then we'll have an
yeah.
understanding
We'll
more.
come to that. No worries, no worries. We'll go one by one. Okay. Sure, I took your point, but as I said, we'll go through all these layers one by one as we move on. Okay, and where on which layer the device, or sorry, what device uses which layer of these seven? We'll go through that one by one. Okay, so as I was saying, these layers are present in your our laptop. Okay, as I said, this is your laptop, and imagine this is your friend's laptop. And as I was saying, your laptop is a networking device. It is connected to the internet. Okay. And on your laptop, these seven layers are present. Okay. Now, the Facebook or the Zoom session that we are running on the screen that you're watching over the Zoom session is actually running at the top there, which is called as the application. So let's say that someone typed a message. Okay. I see there are few messages on the chat, right? So whatever you're typing, whatever you're viewing, or whatever you do on an application, you're surfing on the Google or website, or you're watching Netflix, everything is happening at the application layer of your device. Okay. Now, what happens is that whatever, let's say you and your friend are speaking to each other or chatting with each other over Facebook or WhatsApp or whatever messaging app you can think of, right? So let's say you typed hi. Okay, you typed hi. Now what happens? This hi is being typed over Facebook, which is running at the application. Now, please remember this particular part very carefully. What happens is that the hi message that you have messaged gets, or it is sent to the layer that is below, which is the presentation layer. And this presentation layer basically covers, or it's like an envelope. Okay, it's like an envelope, or you can think of a sixth layer envelope. If you open this envelope, sixth layer envelope, you will see the hi message. Okay. Now what happens? This sixth layer gets enveloped or covered inside a session layer or the fifth layer, then the fourth, then the third, then the second, and then the last, the physical layer. This kind of covering up or this kind of enveloping of data is called as encapsulation. Okay, to remember this word easier, think of tablets or capsules. Okay, if obviously we all of us have like fallen ill, we have taken capsules. Capsules basically is in a cylindrical shape. Okay, with one color here, with the other color over here. And if you ever have broken the capsule, you will see smaller balls, medicine balls inside this capsule. It's a similar way how basically your data gets encapsulated inside the higher layer and then is sent down to the bottom layer. Okay. And as I said, the only layer that you can physically touch and feel is the application layer. Okay. You can view it. Zoom, as I said, we are talking over Zoom. You can view Zoom. Okay. And the layers sixth, fifth, fourth, third, second, you cannot touch and feel. Okay, you can only just imagine. And this is my work of letting you understand the imagination and trying to make you or give you an understanding of what is happening in these layers. Okay, and then the last layer, which is physical, as I said, it can be touched as well. And in this physical layer, you will see the wires that are coming from your laptop. If you're connected to an Ethernet cable, you will see the cable. Cable is a part of physical layer. Okay, physical. The word itself means physical. You can touch and feel it. The Wi-Fi router, which is connected on in your home, or the LAN cable, if you're sitting in your office and you're connected through a Ethernet LAN cable, you can touch and feel, right? That is physical medium. And what happens? This at the physical layer, what happens? Your data gets converted into binary format of 10101010 or whatever combinations of ones and zeros. I hope we understand what's a binary. Okay, basically the data is converted into binary bits of ones and zeros. Then it travels through the physical world, meaning physical world of wires. And 99% of our internet is wire. Okay, we are connected to our friends and families across the globe through wires only. Okay, so it travels through wire and it reaches your friend's Wi-Fi modem, right? And your friend's Wi-Fi modem then starts to, this was encapsulation. Your friend's Wi-Fi modem sends this data to your friend's laptop, and your friend's laptop starts to decapsulate it. Your friend's laptop starts to decapsulate it. It starts to open each and every layer one by one. Okay, revealing the data inside every layer. And finally, when your friend's laptop opens up the presentation layer, we'll talk about presentation layer later. Okay, it sees the application layer, or basically the Zoom or the Facebook in our scenario. Okay, and then when your friend's laptop opens up the application layer, he will see the message sent hi over Facebook. And this is how your data is basically traveling from your computer or your device to the other device. Okay. And again, I'm repeating, we are here to understand how this data is traveling between your laptop and the end device. All right. Any question or anything you want to add or you want to understand more? All right. Now, as I said, we'll talk about these layers one by one in just a small glimpse. Okay. Let's start with the first and foremost layer, which is your physical layer. Okay. As I said, physical layer involves wires or the physical medium through which your networking device sends data. Okay. That's the study of physical layer. Okay, so over here you can see there is an HDMI cable, then you have a RJ45 cable, then you have not HDMI, AV DV cable, then you have an HDMI cable. Here you have an optical cable. Here is a USB. All of these are kind of wires which help us to transfer data, right? And our first, I would say, I'm not sure about others, but for me, my first interaction with these wires was in the computer lab of my school. Okay, so in the computer lab, I had seen such wires, okay, which were connected to the CPU. Those days, we we there were no laptops. There were computers with a CPU, right? So there was a socket like this, which then gets connected to the Ethernet port of the CPU, right? So that was my first interaction, or interaction with the cable in the school lab, right? And to the study, or if you are a field engineer, you would have heard a lot in the field of networks. Field engineers, okay, field engineers basically they work with the physical world of the device, how to connect the cable, okay, to how to connect the cable, or working with the chassis, or working with the hardware, etc. That's basically come into physical study in the physical layer. And network engineers, as network engineers we mostly deal with these three layers. That is your second layer, third layer, and your fourth. Okay, as network engineers, okay, we deal with only these three layers. So if you are a field engineer, okay, you would have dealt with these things in your life, and understanding how these wires are connected, how they transfer data is also important. Okay, so this is what we basically see in the physical layer. Any question or anything you want to add here?
Hey, Laksh, maybe just one question.
Yeah.
Uh, my laptop is wirelessly connected to the router on modem. So that is
Hmm.
also kind of a physical layer, or it falls into some. Uh,
So yeah, so your Wi-Fi adapter, the Wi-Fi adapter of your laptop is part of physical layer, right? Similarly, your Wi-Fi modem, okay, Wi-Fi modem or Wi-Fi router, it also has a Wi-Fi adapter. That's a part of the physical layer. And then your Wi-Fi modem is connected through a cable, right? And it goes outside your home. This is part of that wire, is a part of physical media or a
Understood.
physical layer.
Okay, okay. Yeah, thanks.
Anyone else? Anything you would like to add or ask? All right. Now moving to the second layer, right? Data link layer. Now, before we try to understand what is a data link layer, let's try to understand a bit of a history about it. So my understanding is that the computer, okay, the first computer that was created was to make the mathematical calculations easier for us. Okay, it was created to do faster mathematical calculation, complex mathematical calculations in a matter of seconds. If we take, probably if a complex mathematical calculation back in those days took particularly 1 hour or 2 hours, a computer which with good logical capacity could do that in probably 5 minutes or something, right? And as the processing, as the complexity of the computer started to increase, that calculation became in microseconds, right? Anyway, so my understanding is that the computer was created to do mathematical calculations faster. And as technologies developed, as more and more research came into existence in different fields, computers started to grow in different areas as well. And we wanted to share these research, or we wanted to share our findings with other. Okay, so as we started having more and more computers in the same location, and as I said, we wanted these computers to be connected to each other so that they can share information. Okay. So this is, let's say, computer number one. And if I interchangeably say PC, please understand it, I'm talking about computer only. So computer number two, computer number three, computer number four, right? And as I said, we wanted these computers to share information with each other. So what I did, I connected one computer to the other computers in the same area. So in this example, or in this topology, I have four computers. Okay, PC number one is connected to three other different PCs. So one PC is connected to three PCs. So you need, in a single computer, okay, in a single computer, you need three connections. Okay, or you need three plugs or three ports. Okay, we can you like on our laptop we have USB ports. Similarly, we wanted three different ports so that the wires can be, or three different computers can be connected. Imagine there are 100 computers. As technology started to grow, as more and more computers started to be created, let's imagine there are 100 computers in a university. Okay, so obviously one computer would be connected to 99 different computers. That means you need 99 ports on a computer. Imagine your laptop or your computer having 99 ports. How ugly that would look, right? And there will be only ports, nothing else. Your laptop won't be looking like a laptop. It would be looking like a huge box with a lot of different ports, right? So that, first of all, was not feasible. Okay, it was feasible, but it was not doable. It's a time taking process, etc., to connect the wires then to different 99 ports, 99 other computers, etc. And obviously, if you think from a university perspective, these 99 computers may not be in the same area. They might be in some other building, etc. The wire length may differ, etc. There was a lot of confusion, chaos, etc. going on. So we created a device. Okay, we created a device which was called as a hub. Okay, and we connected these different computers or PCs to the hub. Now the work of a hub was, if any one PC sends a data or sends some file or some information, this hub will duplicate that particular data and send it to all other PCs. This was the work of a hub. Okay, and hub was the first unintelligent networking device that was created. Unintelligent networking device. Why is it unintelligent? You'll understand in a bit. So hub made things easier. So even if I connect 99 PCs together, I want these 99 PCs to be connected to the hub alone. And if one PC sends the data, the hub would duplicate or create 99 copies and send to the other 99 devices. That made things easier, right? That made things easier. But then we are human. We wanted that not all 99 devices should receive this data. We wanted that not all the 99 devices should receive this data. If one computer sends a data, it should be received only by 25 devices. It should be received by 25 devices only. The rest of the 74 other devices should not be able to see that data. Or, for example, see this particular diagram. Let's say these two guys are from physics department, and these two guys are from, for example, chemistry department, right? And if they were connected to a hub, let's say this was physics department and this was chemistry department. So if a chemistry teacher sends a question paper, okay, this question paper would be sent to all the other teachers as well, which probably was not required. And hence we wanted a better thinking capacity for a hub, so that it would send the data only and only to a particular device that we wanted. And hence we created switch. I'm sure you would have heard this word in the networking, switch. If you have not, don't worry, we'll discuss switch in detail in the for the classes. So switch was the first intelligent device. I would say it's the first intelligent device. Why? Because, as I said, if the physics professor sitting on PC number 1 wants to send a question paper to physics teacher at PC number 4, he can send the data. He can send the question paper. The switch would send the data only and only to PC number 4. Okay. Similarly, chemistry teacher number 2 can send the data or the paper to chemistry teacher number 3. And how was that possible? That was possible because we started using something called as a MAC address. Don't worry, we'll discuss about MAC address when we discuss layer 2 in depth in a proper session. This is a demo session. I'm not going to go much deeper into MAC address. Imagine address. It's an address. Just like we have addresses for our houses. For every location in this world, we have an address. Similarly, we created address, and based on that address, the switch was able to send the data to a particular device only, and other devices will never ever see that data. So the switch was the first intelligent device. And we will talk about this MAC address, how your computer, how different devices or networking devices make use of this MAC address. And this MAC address is part of your layer 2 or your data link layer of the networking device. Okay, we'll talk about this in depth about MAC addresses, how MAC addresses are used at the data link layer of any networking device. All right. Now, what happened was I could use this switch. Okay, before I move on, any question regarding this? Anyone? Okay. Now, what I can do with the switch was I could create a small network of different computers or different computers at different locations as well. Meaning that this is a switch, for example, connected to multiple PCs. I'm not drawing a PC over here. Just imagine they're connected to PCs. Let me just draw. They're connected to different PCs. Okay. Now, this is at, for example, geographical location number 1. There are other PCs as well which are connected to a switch. Okay. And what I can do is I can connect these two switches together, and the PCs that are connected to these switches can also communicate now with each other. So with the help of a switch, I can expand my network. With the help of a switch, I can expand my network to whatever distance I want, or to whatever radar that I want with the switch. Okay, so what is happening? I'm forming a small area of networks. Small area of networks. This is a network. I connected it with other network, and thereby I created a small network using just switches. Okay, and hence the name came as local area network, and which we commonly call as LAN. Okay, so small area of network where you connect different devices to a switch is a local area network. Okay, so we will talk about LAN in layer 2 as well. Okay, we'll talk about LAN, how your computer gets connected to a or gets part of a small LAN network. Okay, and in a life of a network engineer, this for him, this is what a LAN looks like. For him, this is what a LAN looks like. So you can see there are switches which are connected through wires to different devices of the network. For a network engineer, this is a network. You can see this is a picture of a server room, which is neatly wired with different devices. Okay, so for a network engineer who has seen a server room, this is what a small LAN would look like. Okay, connecting multiple devices to multiple wires together. Okay, any question? Anyone? No. All right. Now coming to the next layer, that is layer 3. So I just introduced LAN. Right? You can see here, this is a LAN. This is a small LAN, meaning small area of networks. There are multiple devices connected to each other to a switch. You can see this is how a switch is basically denoted in a networking diagram. Okay, and this is also a small LAN. This is also a small LAN. Now, if you want to connect two different LAN network together, if you want two different or multiple LAN networks to be connected together. Okay, that connection, okay, the interconnection of LAN is called as WAN, wide area network. Wide area network, where you connect different LANs together. Okay, and this wide area network that you see in the diagram is what we basically call as internet, interconnection of networks. This is a network, this is a network, this was a network, and we are interconnecting different networks together and hence forming an internet. Okay, and 85% of the time, and a network engineer would be dealing with the wide area network in his daily roles and responsibilities. Okay, now to understand this even more or in a better way of what we will look at in network layer, we, as I said, in the data link layer, we will be learning about MAC addresses. We will be learning about how MAC address helps or a switch to forward data, etc. Similarly, we will be learning about things in the network layer as well. But to visually understand it, let's take this example of our map. So you can see this is a small snippet of South India map. Okay. Now, imagine you are at Coimbatore. Okay, it's a small city. It's a not small city. It's a city in Tamil Nadu. And from Coimbatore, give me a minute. So Coimbatore, as I said, is a city in Tamil Nadu. And from Coimbatore, I want to travel to Chennai. Okay. So Coimbatore is my source where I will be starting, and Chennai is the destination where I will end my journey. Okay. And in this example, I'm only considering road travel. I'm not considering train. I'm not considering air travel. I'm only considering road travel only. Okay. So from Coimbatore to Chennai, I have different ways or different paths to reach Chennai. The most and the best path and frequently used path is a direct path from from Coimbatore to Erode, Salem, Tiruvannamalai, and Mahabalipuram and Chennai. Okay, this is the direct and best path. So if you search from Coimbatore to Chennai on a Google map and check the route, it will give you this path. This is the best path. Okay, but this is not the only path to reach Chennai. You have different other paths. You can go to Chennai like this. You can go to Chennai via Ooty, Mysore, Bangalore, Vellore, Chennai, etc. Okay, you have different paths to reach Chennai. Okay. Similarly, in a network, in computer networks, the Zoom application that is running on my device, okay, is sending you data over the internet through different paths. It's not necessary. Let's imagine I am sitting in Coimbatore, you guys are sitting in Chennai. It's not necessary the data path will take the direct path. It may take a longer path as well. It may take this path as well. It may take a shorter path. And which path will it take? Which road will it take? Longer, shorter, everything depends on the decision made in the network layer of a device. Okay. Now, to understand it even better, let me give you an example. The roads. Okay, the roads that we see over here, which are already laid. It's not the duty of a citizen to lay the road. It's the duty of the government, right? To lay down the road from Coimbatore to Chennai, and multiple roads, not just one road, multiple roads. These roads in networking is called as IP, Internet Protocol, IP, Internet Protocol. Okay, as I said, government has already laid the roads. Similarly, there are institutions, there are networking institutions. IEEE is one of them. There is IANA, which assigns IP addresses. These are few of the institutions which have already laid down the networking road, which is called as the IP, Internet Protocol. They have already laid down that road. Okay. Now, obviously, on the roads, we are using vehicles, right? We have vehicles. Okay. For vehicles, we may use a car, we may use a bus. Okay. We may also use a bike. Okay. We may also use a bike. Or if we are if we go back to a time when there were no transportations, people used to walk as well. That's also a mode of transportation. We can take the road as well to walk. Okay. So these modes of transportation which are using the roads in networking, they are called as routing protocols. They are called as routing protocols. Okay, so these routing protocols, which are the vehicles of networking, they use the road, which is the IP, in order to move from a source to a particular destination. All right. Now, roads have different lanes as well, right? We see a two-lane road. We may see a 4-lane road. We may see an 8-lane road or a 6-lane road, etc. Okay, there are different lanes on a road. So basically, the width of the road increases, right? And these lanes in networking, we call them as bandwidth. We call them as bandwidth. So now, if you're discussing with a network engineer, you would have heard this word bandwidth a lot. Bandwidth. Higher bandwidth means faster moving of traffic. Imagine yourself, you are moving, you are taking a 2-lane road. Obviously, your speed would be low. Why? Because there will be a lot of cars or vehicles on your path. There will be incoming traffic as well, right? So overtaking and moving faster is not possible. As you move into an 8-lane road or a 10-lane road, obviously 10-lane road is not there. 8 lanes are present in India. 8-lane road. So 4-lane on one side, 4-lane on the other side. Imagine 4 lanes just for one direction. You can move faster, right? The same way, bandwidth also applies in networking. The higher bandwidth, like in when you are asking for internet connection from Airtel or Jio or Tata or anyone, they say we are giving you a bandwidth of 150 Mbps, or they say we are giving you a download speed of 200 Mbps. Basically, it is the bandwidth. If you have low bandwidth, let's say if you have just 50 Mbps, your plan is for 50 Mbps. If there are too many people in your home and they're using your internet or your Wi-Fi, your internet speed may become slower. But if you have a 200 Mbps plan, even if there are 10 people in your home and they're using your Wi-Fi modem or your Wi-Fi internet, you are watching a movie. Your movie, what do you say? Movie. I forgot the word. Uh, enjoyment will never be interfered. The visuals or the resolution will never ever decrease because you have a higher bandwidth. The traffic can flow easily. And as I said, bandwidth is what we call in the internet terms. Then, obviously, when you're traveling, you will be crossing different locations, right? So I'm traveling from Coimbatore and I'm taking the straight or the best path. First is the Coimbatore, then next city, Erode, Salem, Tiruvannamalai, Mahabalipuram, and Chennai. So these locations in networking are called as a device, which is called as a router. Router is a physical device which basically helps to connect the wires over which these IPs are laid out. Okay, so your different locations are these routers. So from one router, the data is sent to another router. This router will send the data to the next router, next router, next router, and finally the destination. Okay, and lastly, the passengers. Passengers. Who are these passengers? Okay, car. Car is a vehicle. Bus is a vehicle. Bike is a vehicle. Walk, obviously, you're walking. So each of these different vehicles are carrying passengers. Okay, depends on the type of car. It can be a 5-seater car or a 7-seater car. Bus can be a small bus, a big bus. Bike, 2 people. So they are carrying passengers. And in networking, that is called as data. So, right, your data is being carried by these routing protocols on the road of IP. All right. Any question, understanding understanding this part? And we will be learning about these routing protocols, these bandwidth, these IPs, etc. at the layer 3 of the network, layer 3 of the OSI or a TCP model. And as I said, these decisions, what is the bandwidth? Which road should it take? Which vehicle should it take? What is the bandwidth? All that is decided at the layer 3 of a networking device. All right. Any question, anyone? Okay. Moving on. Okay. So this is a very common thing that you would have seen when you are on your WhatsApp. Okay. So these things you would have already seen in your WhatsApp chat, and these are few snippets from the WhatsApp itself. Okay. Now you can see here. Let's say you sent a message to your friend. Your WhatsApp chat shows you the message is sent. Right. You will see a single tick. Single tick means the message is sent from your mobile phone, but it has not, but it is not received to your friend's phone. Right? When it is received, you will see a double tick. And when your friend reads that message, it will give you a blue tick mark. Okay. We will have seen this. We usually see this every day. And sometimes when you're sending a picture or when you're sending some message, you will see not delivered message. Or sometimes when you are opening, let's say for some reason you had to uninstall, your WhatsApp is not working, or you opened up WhatsApp after a very, 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 very long time, you may see such messages. Waiting for this message, this may take a while. Or you're trying to download a picture. Your friend sent a picture, but the download failed. Right? The question here comes, how does your phone know that this message is sent to your friend, or this message was received by your friend, or your friend has read this message? Or how does your phone know that this message was not delivered? Or how does your phone knows that the message is taking too much time to be received? Or how does your phone know that the download was failed? How does it know this? Everything is, as I said, there are those 7 layers are on your phone, and those 7 layers are on your friend's phone. But the 7 layers on your phone is dedicated only to you, only to your phone. So how does your phone or those 7 layers know that the message is received or read or not delivered, or the download has failed, and it shows you that message? How does it happen? That is where the 4th layer, transport layer of your phone comes into picture. Okay, because of the transport layer on your phone, your WhatsApp message is able to show you these different notifications. Okay, so the work of a transport layer of any networking device is to make sure that you are always, or your phone is always acknowledged. It sees an acknowledgement. The message is sent is an acknowledgement. The message is received is an acknowledgement. The message is read is an acknowledgement. The message was not delivered is an acknowledgement. The download failed is an acknowledgement. And where is this acknowledgement coming from? The acknowledgement is coming from the other side. These acknowledgements are coming from the other side. It's not from your phone. It is from your friend's phone. Similarly, when your friend sends a message, on his phone also, it will be shown that the message is sent, the message is received, the message is read. Why? Because your phone is now sending an acknowledgement to your friend's phone. And that acknowledgement is sent by the transport layer of your phone. Okay, so in other words, acknowledgement gives us in real time, when I say hello, okay, this is me and this is my friend. When I say hello, okay, I will also hear back a hello from my friend, meaning that he has heard my hello and now I can talk or I can have a conversation, right? That is basically an acknowledgement. If I say a hello, you should also say back the hello. If I wish you a good morning, you wish me back good morning, right? That means you heard me, correct? Similarly, this is what the transport layer makes sure that whatever message you are sending is acknowledged by the other side. Okay, if there is no acknowledgement, let's say I sent or I said a hello to my friend. Let's say he did not hear me. He did not hear me and he did not say a hello back. So I will say hello again. Hello. Imagine you're talking on a phone. You picked up the call and you said hello, and you did not hear back a hello from the other side. You keep saying hello, hello, hello. Basically, you're waiting for an acknowledgement from the other side. You're waiting for the other person to say hello or say hi. I'm this person. Are you this guy? And I'm calling you for this regards. So you're basically waiting for an acknowledgement from the other side, right? And as I said, that is the purpose of the transport layer. It makes sure that whatever data that you send is acknowledged back by the other device, so that you are sure that your data is sent on the other side and is heard by the other side, and the data from the other side can also be received. That is the work of the transport layer of any networking device. Clear? Any question? Anyone has any question regarding this? All right. Now, the last layer, that is the fifth layer, application layer. Now, you may ask, why is this the last layer? Because as I showed you, there are two types of models. One was an OSI model. The other was a TCP IP model. Okay. In the TCP IP model, your your 5, 6, and 7 together is called as an application layer. Okay. Let me go back to the diagram. Here. Okay. So the fifth, sixth, and seventh layer, which we can clearly see as session layer, presentation layer, and application layer, is mentioned in the Open Standard Interconnect or OSI layer mode. These three layers are clubbed together These three layers are clubbed together and are called as application layer in the TCP/IP protocol. In the TCP/IP protocol, though the work remains the same, the work of these three layers remains the same. However, in the TCP/IP model, they have been clubbed together into a single layer, which is called as the application. Okay. Now, sorry. Okay. Now let me show you a real-time example of what would happen. You would have heard this interview question a lot. What happens when you type netflix.com? Okay. When I press netflix.com and I press enter, you would see it is buffering. It is buffering, and then the Netflix page opens up. The Netflix page opens up, right? So the application layer, basically, as I said, application layer is the only layer which you can feel and touch. The whatever you are seeing on your screen is basically you're viewing on it on the application layer, right? So application layer basically gives you the result of the internet communication that you're doing. If you search for google.com, it opens up the Google page. If you search for facebook.com, it will open up the Facebook page, right? So in application, we study how is this happening. So basically, application layer completes the whole discussion that we had just now. Okay, so what is happening in the application layer? You type, let's say, google.com or facebook.com or netflix.com. So what happens? This google.com or facebook.com or a netflix.com is a human name, is a human readable name. Okay, I understand what is Facebook. I understand what is Netflix. I understand what is Google name. But a computer which understands only ones and zeros, and in the world of internet, it runs on IP address, which is at the layer 3 network layer. It understands only IP addresses and ones and zeros. It does not understand Google. It does not understand Netflix. It does not understand Facebook. So what happens? That name should be converted into its equivalent IP address. That happens at the application layer. Then a reliable communication between my computer when I type a google.com and the Google server happens. That reliable connection happens because of the transport layer. So that whatever I type is acknowledged by the Google server. That reliable connection happens because of the transport layer. Then, right, because I typed google.com or Facebook, what page have I opened? Yeah, facebook.com. The logo of the Facebook, these things that is written at the bottom, and this pop-up for entering the password, create a new account, create page, whatever you see on the web page is a data, is small data that my computer asked the Facebook server. So small information, send me the logo of Facebook, send me the web page of Facebook, etc. It asked the Google server, sorry, the Facebook server, and the Facebook server acknowledged. When this Facebook server acknowledged, you see this page. So the data is basically traveling. Like when I typed google.com, yes, things happened, but in the behind, the data is taking the IP road. It is using routing protocols to transfer my data through different routers to reach the Facebook server. Then the Facebook server is also using the same IP or the same roads, using the vehicles, and through the routers, it is sending back the data to my computer. Right. So all this is happening at the application layer. Okay, application layer is telling you the end result, but behind the end result, we just saw what happens. And this is what is the study of computer networks, how things are connected to each other, how we are able to talk, how we are able to view, how we are able to view our favorite match, how we are able to view our favorite movie on the internet, etc. Everything that is the study of internet. Okay. Any question, anyone, about the whole application layer or the internet? Anyone? No? Okay. Now, regarding the timing, timing is a bit odd. Okay. Because of a few of my personal commitments, the timing of this course is from 10, not 10 p.m., sorry, is from, yeah, sorry, 10 p.m. to 11:30 p.m. I know it's a bit of an odd timing. As I said, because of my few of my personal commitment, I will be starting this class at 10 p.m. and it will happen on weekdays, Monday to Friday, 10 p.m. to 11:30 p.m. And as I said, it's an open session. Anyone can join, and it's a free session. Again, it's not a paid one. It's a free course. Anyone can join. And this will be a recorded session. Even this demo session is being recorded. This demo session is being recorded, and you can watch this recorded session on YouTube on my channel as well. Okay, and you can also see it on my website. Okay, so for YouTube, you can go to Network Bytes. Network Bytes with Laksh, you can search there. These recordings will be uploaded there as well. And on website, again, networkbyteswithlaksh.com. Okay, so you can see that there as well. I will be creating the course on the website soon. And once if you would like to see the recording over the website, all you need to just enroll yourself on the website to the course, and you can view it as you wish. So you can view it on YouTube, you can view it on website, etc. And it's not just this particular course that is available on my website. You can, if anyone is interested to learn more on computer networks, I have a lot of other courses as well. I have the CCNA, CCNP courses as well. We'll talk about these different courses as we go through the demo sessions one by one. But if anyone else is interested in any other courses, I have the interview series course as well. There are different free playlists as well. Okay, so there are videos in three different languages, Hindi, Tamil, and English. Okay, so currently there are only two live courses going on. One is the CCI Enterprise Bootcamp course that is in progress, and one is this one, CCN. Not CCN, the Networking Basics to Advanced course. These are the only two live sessions that is going on right now. The others are recorded. So you can, if anyone is interested in any other course, you can enroll yourself there as well. Okay, so if you're not able to join in this particular timing, it's okay. As I said, it's recorded and it will be available on YouTube and the website as well. So you can watch at your free will anytime. Okay. And I would request everyone, whoever is present today, to please let your friends or colleagues know about this course, about this, because it's a great course. I guarantee that I make sure that you like computer networks, you understand what computer network is all about. you understand what computer network is all about, and I make sure that you are comfortable, your foundation in the computer network is extremely strong. All right. Now, before I end this session, anyone has any question, or would you like to add something before I end this call? Anyone?
Hey, Laksh, no questions from my side, and I think it was a really good session. So thanks for conducting this. I quite often see your emails on that Bangalore masala. But
Yeah.
I never thought that it would be this much helpful. I think I will continue if time permits. I will really continue to come to these sessions, even though I know the timings are odd. But I think it's worth to be present in the live sessions, because I see that most of the questions or the way you explain is really good. So I think it would be helpful to me. I don't come from a very technical background, even though I was as a hardware engineer for quite some time. But currently I'm in the operations, but my work requires the information regarding the edge core and those the access points and those understanding as well. So I think it's really helpful. And once again, thank you for conducting this demo session. I think I will continue to join the sessions. Thank you.
Thank you, Jay. Thanks a lot. Thanks a lot. Anyone else has any questions or anything to speak about, or else we can close this session. And yeah, before I close the session, this would like the proper sessions would start from today's second, 6th of October. That is Monday. Monday, 10 p.m. to 11:30 p.m. 6th October.
Yeah, hi Lex.
Hi, Naresh. Yes.
Yeah, actually, do we have any like WhatsApp channel or anything? Like how we can join these sessions? Are you sharing links in where you are sharing?
Yes.
Right.
Did you register yourself on the link that I shared? Because I have like.
No, I received this from my friend, one of my colleague. So I joined.
Okay, no problem. Okay, do one thing. Okay, can you please share your mobile phone, or just send me a hi over this number 97303 59159. Just send me a hi over this number, and I'll add you to the group. There is a group. Yes.
Okay, thank you, Lex.
All right. If no other queries, I'll end the call. Thank you, everyone, and have a great day and happy Dussehra. Thank you.
Yeah, thank you, sir. Thanks
Thank
for
you.
the.
Thank you.